Hi, everybody. I'm JR from 3DHerndon, but welcome to From Powder to Product. This is going to be talking about the integrating Desktop SLS into your everyday workflow. And we're going to be going over, basically a lot of SLS things and just, 3D printing in that genre in general. But to kind of start everything off, like I said, my name is JR Bontrager. I'm the 3D specialist here at 3DHerndon, and I'm being joined by, on whichever side, Mr. Radek from Sinterit.
Yeah,
go ahead and introduce yourself. Tell us a little bit about Sinterit, sir.
Hello, everybody. My name is Radek. I'm from Poland, from Sinterit. We are a company who is delivering 3D printing solutions to the markets since 2015. So we have quite an experience, and we delivered over 1,000 laser sintering systems around the world. So we know how to do laser sintering.
Absolutely, they do. And we want to, of course, thank everybody for joining us, but we want to thank Tomasz and, of course, Bakia, Tiana, and everybody else on the back end that's going to be helping us answer questions as we go through as our moderators. So any questions that you have, feel free to go ahead and ask those down in the chat right there. If you have a specific question, we are going to be doing a Q&A at the end. So that's one part of that. So we'll get into our other bit of housekeeping here. This is being recorded, so you will be able to have an access to this after the webinar is complete. So that way, if you want to watch it again at your leisure, you can do that. So there we go. Also about the platform, if you've never used GetResponse before, at the bottom, you can go ahead and type in any of the questions that you have, and our moderators will select those out so we can answer those a little bit more in depth at the end, or we'll be able to answer them as we kind of go along. There's also a hand raise if you want to put that in, just to make sure that if you have a very specific question, they can address it very quickly for you, especially if you're having trouble seeing the videos, having audio issues. Just raise your hand and the moderators will help you out as best as they can. So what's going to be happening today is we're going to talk a little bit about SLS. We're going to talk about what the process of the 3D printing is. We're going to talk about the advantages of it and why it's better in desktop form as opposed to large industrial. And then we'll be talking about the design possibilities in SLS, because it's a little bit different than probably something you may have encountered with SLA or standard FDM, FFF kind of design possibilities. We're going to give a brief look at the materials, and I'll talk a little bit about how SLS can benefit you as a user. And then, like I said, at the end, we're going to talk a little bit about just answer some questions that you might have. And believe me, we've added in a little bit of time for this webinar to answer all the questions that you have. Since SLS is kind of a newer technology, we know that there's a lot of questions out there. But to kind of get everything rolling, we'd like to ask you a question, our great audience here. What types of 3D printing and additive manufacturing do you currently use in your workplace or even at home? What are you familiar with? This is going to kind of help us, move through the webinar and kind of pre-answer some of the questions that you might have. So we'll give you a few seconds here to go ahead and add those responses. Oh, yeah, already got Lisa uses already. Love it. Love to see it. It's going to be great. Radek, you're looking awful sharp today, buddy.
I'm trying my best.
There you go. There you go. All right, so we'll give that another 5 seconds here, and then we'll go ahead and just fill it out ourselves there. All right, so let's go ahead and see what we're working with here. Tomasz, what were our answers here for everything? The anticipation is killing me.
Yeah, we are close to seeing the results.
There we go. All right, so we got a pretty good amount of FTM, SLS, got a couple of SLA users. Some multi-jet fusion and some others. So fantastic. All right, so we got a pretty good spread. So that's great. I don't have to get too crazy about 3D printing in general. So that's great for that. But let's talk about SLS. What is SLS? How does it actually work? Well, For the Scrabble users out there, it's selective laser sintering. Essentially what it is you have powder that's being fed from a feed bed to a print bed with a little recoder that comes by and adds in your layers, and then a laser actually sinters the powder together as it kind of goes through. As you can see, the majestic pointing, because I'm pointing in thin air, like you can see that right there. But yes, so it's a very simple process. There's a lot of materials that you can use this for. It gives you a lot of strength, a lot of durability, and a lot of flexibility depending on the materials that you're using. So selective laser sintering is a very, very unique way to do 3D printing and additive manufacturing. So who uses SLS technology? Who's using the Sinterit right now? Well, here in the North American market and through most of the world, we've seen a large quantity of this particular type of printing being done by educational institutions, universities, both large-scale and small universities, as well as some higher-end high schools have been doing this. And the big portion of this is that additive manufacturing and 3D printing are basically the wave of the future. So getting young people engaged in this kind of technology is kind of how we're going to move forward in the future. So it's going to be pretty. Pretty essential to kind of get them hands-on training for this type of manufacturing. Now, the other thing to kind of keep in mind is this is strictly just the SLS. We're not including all the other types out there, but this is important because desktop SLS. Now, normally you have these $100,000-$200,000 machines that no professor is going to let you touch these things. So having a desktop SLS come in, you're a lot more comfortable having newer students after they have a little bit of training being able to use this kind of thing. So it's really important that desktop SLS kind of make its way in, and that's usually kind of the foothold that we see, is that a lot of people are like, well, I don't want to put in $100,000 or an exorbitant amount of money and then have to train an engineer on how to use this. You can literally take one of these desktop SLS machines and after about an hour or so, anybody can really use these. There's a couple of things here and there that you might need to have a little bit more experience with, but for the most part, desktop SLS is pretty easy to use and pretty easy to kind of get moving through the learning curves. Not too bad. But we also have a lot of people in manufacturing, engineering, research, development, all kinds of things. There's a pretty widespread, and in there we also have a lot of medical. That goes into a lot of our research and testing is medical, because we see a lot of things going on with that, especially given the current pandemic going on. Sinterit has done an amazing job at putting out a lot of personal protective devices that have come out of the Sinterit in large quantities, which has been fantastic. So definitely something to look into for that. Now, what are the advantages of desktop SLS? Well, there's a lot, really. The biggest thing, especially for me as a maker in general, it's the no support structure needed. This is like the greatest thing since PVA was invented. The no support structure is because you can have your model and it's basically in sand as it goes. So it's already supporting itself with the surrounding sand. So once you're done, you can literally just pick it out, dump out the sand that's internal, and then your part is ready to go. It's amazing. It's so great. Saves you a lot of time in the back end. You don't have to wait for PVA to dissolve. You don't have to wait for somebody to clean off the support structures. You don't have to train somebody to give it a special sort of chemical bath. It all just comes right out, just like sand. It's great.
And it's worth noting that all this powder that you haven't sintered, you can reuse it again. So you are not wasting any material, because you are not dissolving into the water material, which is quite expensive. You can reuse all of it.
That's exactly right, Radek. Yeah, and that is a big point to have. I missed that on my notes. I don't know how, but I totally did. But yes, you can reuse. There's just a little bit of refresh that you add in to kind of keep the powder maintained, but it's still the industry leading as far as Sinterit is concerned. Still the industry leading in that material refresh rate. The other big advantage that you have is nesting. Now, if you imagine that FDM and SLA is basically like you own a parking lot. You can only put certain amount of cars in your lot. And then from that's it. You know, once that lot is full, you have to have another lot to put more cars in. SLS is a lot like having a parking garage. So you can stack more cars on top of it as you go through to fill up that build volume. And nesting is how you do that. So you can put parts inside of parts, inside of parts, inside of other parts at different angles. And again, because there's no support structure, you don't have to worry about, oh, am I going to have to clean this out of PVA? Am I going to have to do this or that? It allows you to get a large amount of your project printed at one time, which is amazing. And because of all that, because of your nesting, because of their lack of supports, you can have movable parts. So things can immediately come right out of the printer and be ready to move. Springs can be 3D printed, axles can be 3D printed, all kinds of really amazing things can be done strictly right out of the powder just from how you design them. And this gives you a really good way of kind of judging if what you have has the right look that you're going for, if it has the right clearances that you're looking for, and more importantly, it functions the way that you want it to. And so there's a lot of really interesting things that you can do for that. So thank you for zooming out on that. So again, talking about nesting, when you see it all nested in, you're not really sure how many parts are in there. All of those parts are in that nest. So that's a lot of parts that you can get done. And again, through simple post-processing afterward, just sandblasting to make everything neat, clean, ready to go. It's great, fantastic. You don't have to wait. Again, you don't have to wait for a chemical bath. You don't have to wait for stuff to dissolve. You just slap it into a sieve, add in your refresher, done, perfect. You can get the whole process done very, very quickly. It's one of my personal favorite things about SLS technology. So how does this relate to you as a cost efficient? What is the benefit to you to being able to do this? Well, let's take, for instance, if you were to do just the one part, this one battery lever, it would be about $20 if you were just to print the one in SLS, because whether you put one part in or 10 parts in, that recoater and that powder still has to go over the entire layer. So it's a whole volume that you get to play with. So it's not really economically feasible to do the one part. But if you're gonna, hey, let's try out this part, let's try out this part, this part, how about this way? You can add those into the same layer and print them out and be a much more cost effective for your prototyping. And if you look, having 170 pieces puts it at less than 85 cents a part. Huge savings. And again, you're not having to sit there, clean out any supports that are there. You can literally just stack it and then put it right back in, and the refresh rate and everything makes it super easy, super uncomplicated, and super cost effective for you. Radek, do you have anything to add?
You covered everything perfectly here.
Oh man, I tell you what, we're hitting it home. So you've heard me talk about how you can print the part, refresh the part, and then post process the part. But is it really that simple? Well, the answer is yes, absolutely. It is that simple. And really it comes down to being able to take it from the printer to cleaning the part off really quickly, refreshing the powder, and then post-processing the part to make it clean, neat, and tidy. And it's literally just those three steps. You just clean the printer, refresh the powder, clean the part. Done. Ready to rock and roll, and it's great. Your part, with minimal amounts of effort on the post-processing, comes out smooth, comes out clean, and comes out ready to use. And the powder, here's the thing. As a side note, this is our number one question. And they actually answered this about 2 weeks ago in a Sinterit webinar where they were demystifying a lot of the things about the powder. People will usually say, SLS, it's really messy. Well, here's the thing. It can be if you're not careful. And the way that I relate that is, if you were to bake a cake and your kitchen was a complete mess, do you blame the stove? No, you don't. You blame the baker who was just moving just a little bit too fast. So if you take your time and are careful with what it is, the powder for SLS is just as safe as dealing with any of your FDM filaments or any of your SLA resins. So as long as you're careful, do your due diligence, personal safety wise, everything is going to be fine, and everything will come out clean. Everything will be fantastic. So that's another one of those things that I would absolutely recommend that you watch is all of the other parts of this series, whether we talk about the powders and things like that from Sinterit. It's great. It'll expand your knowledge even more. So coming into our next part here, we're going to talk about the freedom of design. Now, again, because you don't have to worry about support structures, you don't have to worry about any of the little things that would normally kind of impede your method of design. You can actually use anything that you need to make your design happen. And the SLS printing is extremely high in accuracy and tolerance. So while you're designing your one part, if you just say, oh, I want to be able to like say make this derailleur that you see, well, I want to make sure that it fits correctly for what I want. You know, you can design it like that, make sure that you can get everything where you need it to be, and then that way when you move to actual high scale manufacturing, you know that the part works 100% of the time because you've already tested it in an environment that can take the strain and that can show you exactly the range of motion that you're looking for. So it's very important that you know that prototyping, you can go completely, to use the term ham, you can go completely crazy and completely ham on what you want your part to actually do, which is great. And there's near limitless freedom, living hinges, everything can be designed and printed in the SLS powder. And then when we talk about materials here in a little bit, you'll see there's a lot of material composition that you can actually use as well. Now, when it comes to design, you can design it with confidence. Like anything else in additive manufacturing and 3D printing, there's always those minimums that you have to have and those recommended steps. It's for everything. SLS is no different. But what is different is the fact that your wall thicknesses, your resolutions are far better and far more accurate at those resolutions than a lot of the other ways of additive manufacturing and 3D printing. And not to mention your base tensile strength for your PA12 nylon is pretty good as compared to most other things in the business without actually having to injection molding it and spending that kind of money to run tests. SLS is very, very good at this.
Yeah, and it's also worth noting that you can have a design that really works for your application, and you can have not just a standard design, but design which is suitable for what the forces are going to be on the element that you are designing. So you have also this possibility, which is not possible with standard means of manufacturing.
Yeah, which is very true, and with a lot of designs right now going into generative designs and generative simulations, SLS really holds well with that kind of design. Absolutely, Radek. So now let's talk a little bit about materials. Now, material selection is, of course, as important as anything else. Now, with SLS, there's a lot of different things that we can do. But today, we're going to be focusing a little bit more on what the Sinterit has to offer, because they have one of the largest selections of standard powders for their machines in the business. So you have your PA12 and your PA11 nylons. You have a Flexa series, which has it comes in gray, soft, and bright. So the bright's really nice because you can actually dye that if you like. And then they have the TPE powder, which is kind of an elasticer, which you can have watertight and airtight with the Sinterit sealer, which is fantastic. So PA11 and PA12 are going to be what you're going to use for a lot of your prototyping or near end use materials. They're great for, like I said, they're great for test fits, snap fits, living hinges. The PA11, super good with impact, temperature resistance. Got a lot, and the flexible TPUs are great for any sort of flexible material that you want to have. This, of course, is a TPE baffle, which we've had sealed, so it's actually water and airtight. So these are really great for doing end-use applications if you want to do anything like that. Fashion has been huge. Medical has been really advantageous for this, so that you can have something that moves and gels correctly with how you want to apply certain things. And FlexiSoft is durable, and it doesn't hurt when it's on your skin, which is fantastic for any sort of like wearables that you might want to have, or any sort of soft application based stuff that you might want to put into. Did I miss anything?
It's also worth noticing that if you have a correct design or the proper design, you can imitate how the material behaves. So, for example, we had a case where the medical institutions were able to imitate with the FlexiSoft the human body tissues, so they can make trainings for the doctors on those printed parts.
Yeah, and that's huge nowadays, because especially with everything going on, you want to be able to kind of get in and out without any sort of complications. So having that ability to kind of test beforehand and understand what's going on in 3D has been huge. Not just in SLS, but just in 3D in general. Just having that capability, it's so good, and especially as we move toward the future, it's going to be incredible. So, Mr. Radek, why don't you tell us about the brand new release today?
Yeah, so today we are releasing new powder from our offer. So this is PA11 ESD. This is the material that gives you another level of possibilities. So not only it discharged any electricity from the model, so you can make casings and many other applications for your design. Any certified parts for explosion areas and so on and so forth. But what's also very impressive about this material is its melting point and softening point, because it really is the material that can withstand high temperatures. Just to mention that it can withstand easily above 100 degrees Celsius under load. So that's a great addition. So I just wanted to get you guys know that we are still developing new materials. We are still developing to meet the needs of the industry, because we are working with industry, and we are working for industry, and not only industry, but this is, as JR said at the beginning, about 60% of our customers are coming from industry, and the universities are training students to make better things for our better future.
Yeah, and what's really great, and as a kind of a side note / sales bit, the Sinterit platform is really great for actually testing powders as well, because it's open. It has the ability to be open to third-party powders. So if you're looking to kind of experiment or do research on powders, it's definitely one of those things that's nice to have, especially at a university level. So Radek, why don't you talk a little bit about our customers that are currently using it?
Yeah, so you just heard from JR what are the main benefits of using this technology, and I just wanted to highlight how our customers are using it, because the pictures that you have seen in this presentation, it's not just our show off. It's those are the pictures from our customers. This is how our customers are using our devices. So this is the proof. So one of our customers is running a production, and he had an issue that our gaskets are not good enough, and they are lasting only an hour, and we have to replace them over and over. And they found out that gaskets they printed with our FlexAgray were much better. So other than ordering it over and over, they can produce them by themselves. And this is only the site's usage of their printer, because they bought the printer to help them with the prototyping and having faster prototyping and having their intellectual property secured. So this is only a bonus for them. So that's great. I also have another example for you. This is the example how this technology helps basically to make the prototypes faster and better. So on this one prototype of this item, this company saved a lot, because usually they were using molding to get molds to make the prototypes, and took a lot of money, and also took a lot of time to get molds to make a prototype and see if design is correct or not. And only with their Sinterit system, they were able to do it over 1 week with all the parts from different materials. So not only PA12 they used, but also flexible materials for other parts, and also they made their own mold to make some custom-made keys for this device. So only after one project they saved so much money that they decided to go forward with expansion of their system.
That's great. I mean, to be able to, again, it's all made possible by the design freedoms that you have with this kind of technology. So that's great. So what we do want to let everyone know that you can definitely get a free sample box from one of our from either Sinterit or 3DHerndon or one of our other worldwide resellers. Just go ahead and click above to get yourself a free sample box. It'll come with a cool little Herndon joint, turbine. So to really show you just a simple thing to have on your desk to kind of remind you the advantages of SLS technology, working parts, things that move. It's great, a lot of fun.
Yeah, and I also wanted to say that depending on your region, where are you from, you can always contact us or our partners in your region, and we'll be able to provide you with the samples that you can experience what we are talking about and see for yourself.
Absolutely. And then, all right. So now we're going to answer your questions that have been going through. I've seen some really good ones as we've been scrolling through. I know Tomasz and the crew have been answering them as we've going along. But let's see what we have in our Q&A.
Any plans on developing some nylon with infused glass on other materials? Max, thank you very much for this question. Yes, we are working on nylons with many different nylon materials, but the process is quite complex and quite long. So we want to be sure that we are giving the best value to our customers. We want to be sure that the material that we are developing, we are bringing to the market, was well tested by us. And we know that a customer will have good results over and over again, that not after one printing process, they will have to throw away all the powder, because it sometimes happens. And also talking about nylons with infusion of glass or, for example, carbon fiber, we have to be concerned about the health and safety regulations, and to be sure that our users are 100% safe to use this kind of material. So we are working on other materials. So we just today launched PA11 ESD. So please subscribe to our newsletter to get to know when we are launching new materials. Yes, so our materials PA12 is resistant to chemicals a lot, so that's that's something that you can use.
Yeah, great question.
Yeah, by the way, as far as I know, PA12 was used in the automotive industry for doing the gasoline pipes as well. So you don't have to worry about this, because this is chemically resistant material a lot. That's correct, Don. PA11 ESD will be using nitrogen, and this is something we didn't mention in our presentation, because it's a little bit for users who are using more advanced materials like PA11 and PA11 ESD. So our printer, as an only on the market in this price range, we are giving a possibility to our customers to use nitrogen. Nitrogen is used, in our case, for more complex materials to stop the oxidizing process and to be able to have a great result. So yes, PA11 ESD will also be using nitrogen. So as you have us here, please feel free to ask a question, because me and JR can help you out with any question that you have.
That's right. If I print a jig with springs, do I print it with springs tensioned or released? Well, that's a really good question. You can actually do that with at tension, and then it will actually benefit from the release afterward, if I'm correct, Radek. You know, as far as the design goes, everything we've done has been at tension.
Yeah. So basically, this is a little bit complex topic on how to design for laser sintering. So I believe this is a question which can inspire us to make another webinar on how to design to have a great result. Basically, you can go to our YouTube channel and see, because we last year or 2 years ago made a webinar about designing for laser sintering. So Wojtek, feel free to visit our YouTube channel and subscribe to it, because we are giving a great value of contents to learn how to benefit from this technology.
What minimum gap tolerance should I allow when designing for moving parts? That's again a great design question. So for that, what we recommend is 800 microns, which is 0.8, or for newer users, a 1 millimeter, just to allow enough of a gap. You can kind of fine tune it a little bit more than that, but our recommended distance is 0.8 or 800 microns.
Yeah, and also what's worth adding is that it really depends on how big the model you are printing. So the bigger the model, the bigger the gap has to be. Also, we have printed the models where the gap is only 150 microns, and it was the tiny models, and in these cases it worked. So getting to know the technology you are designing for will benefit you greatly using this advanced technology. And we only covered a few of advantages of this technology, but there are more of those, of course.
Near limitless.
Near limitless. We are working to bend the limits of this technology for sure.
Let's see if there's any other big Q&A questions. And again, if you have any other questions, and we'll have our contact information here in just a second. So if you do think of anything afterward, you can always feel free to reach out, and we'll be more than happy to answer any of those questions that you have. But again, you can always go to Sinterit's YouTube channel. They've done lots of previous webinars about designing, about the materials themselves. So there's good.
There's another good question about the nesting function in the software. So yeah, we are working on many solutions to make it easier for our customers. But right now, to have the most benefits from using this this technology, we don't find out good enough solution that we are able to bring to our customers. So probably we will have this in the future, but it's really hard for me to tell you when it's gonna land on our software. But I wanted to also add to this that nesting isn't all that hard, and we have worldwide specialists that can help you out with nesting. So it doesn't matter if you are from Mexico, Canada, United States, or Republic of South Africa. You can get a great help. A functioning program would be nice for us to cut out a wall or strive to produce less heat when printing. So this is what we intentionally didn't include it in our software yet, because it depends on. We wanted to make a software which is easy to use for the for users, of course, and we didn't want to mess up with the models they are having, because they will then it will then create some problem where the error was made. So this is not something we are going to implement really soon. But this is something that the designer, as I said before, knowing the technology he is going to use, can think about and design escape holes for the powder and design it in the way that there is less heat generated, and still the properties are as the designer wanted them to be, because we as a company are not able to have good enough algorithm to know what the customers are going to do.
All right. Well, I think that's it for Q&A right there. So we want to thank everybody for joining us. Absolutely appreciate you coming out. Please, a special thank you to our partners, Delray Systems at Ultimate 3D Store here, as well as our other North American and European partners all over the place. We want to thank everybody for definitely stopping by. Please let us know if you have any other questions, either here at 3DHerndon or at Sinterit. Thank you all very much for stopping by. Radek, any final parting gifts of knowledge?
Yeah, I wanted to thank everyone for participating in this webinar, and be sure to subscribe to our mailing lists and our channels, because we are going to have more of good educational content for you in the future. So stay tuned for any other good webinars.
All right. Well, one last. Yep. So yeah, there's a lot of programs out there that you can use for that. Absolutely. All right, everybody, have a wonderful day. Enjoy the rest of the week. And for those of you in North America, have a wonderful Thanksgiving. Everybody, please stay safe as we continue to move forward. Thank you very much. Thank you.
Thank you.